Hi everyone, welcome back to the GCSEMathsPro YouTube channel. Today we're going to be going through the November 2021. Let me just write that down quick. For some reason I don't write it on all of the papers. November 2021, you can see paper 3. Obviously higher tier Edexcel paper. Just making sure it is working. Yeah, there we go. Okay. Yeah, no, I've just started doing foundation because I had quite a few people asking me why I wasn't doing foundation. So I thought I'd try doing foundation, but obviously before our normal higher tier slot at 7. I didn't get many people coming, to be fair, but I don't know. I mean, that might be because it's the first one. Like when I did my first higher tier one, obviously no one came either. I mean, this was obviously back in April, and then it kind of slowly built up. So I'm just going to see how we go during half term, and then I can figure out after a few of them to see if it makes sense to kind of spend my time doing it, basically, doesn't it? If it's actually helping anyone. Yeah, print out the paper, that's fine. I've got it linked in the description, and the mark scheme is also there as well if you want to have a look at that. Actually, I think I need to open the mark scheme myself as well. Let me grab that whilst we're waiting. Paper 3, isn't it? Yeah. All right. Yeah, I think the November ones. Yeah, I feel like it's all the same topics, but the questions just feel different, don't they? Almost like a little bit harder. Definitely, I would agree with that. I don't know if that's actually like reality, but it definitely feels different, doesn't it? I don't know if maybe they make the grade boundaries lower based on that. Possibly. No, grade boundaries look kind of similar, to be fair. Yeah. All right. Okay, let's make a start then. Okay, so question 1, we've got scatter graph. So the scatter graph shows information about the volume of traffic and carbon monoxide level at a point on a road each day for 22 days. Obviously, question 1 is about the outlier. Write down the coordinates of this point. Did I change my profile pic? Oh, you mean Bloopsy? Oh, okay. I was like, wait, did I? No, yeah. So we've got 118, as you said. Yeah, it's just obviously this one over here that's like, it should be pretty obvious which is the outlier, right? It'll just be something completely different to everything else. So it's at 100 and across at 18. Let me scroll down so you can see part B. So part B, for another day, 370 cars passed the point on the road. Estimate the carbon monoxide level for this day. So in this case, it's always, because it's 2 marks, this is always the one where you need to draw the line of best fit. So we'll get obviously you'd get your ruler. Yeah, line of best fit, exactly. So obviously ignoring the outlier one, I just try and get it roughly kind of somewhere in the middle. Maybe, I mean, there's quite a few points here, but if there's a graph where there's fewer points, you could maybe count that you had maybe roughly about the same amount above the line as you have below. In this case, there's so many points, I probably wouldn't bother counting it. So they will give you a slight range as well, because obviously everyone's line of best fit will look slightly different. What am I thinking? Maybe, does that look like it's kind of in the middle? Yeah, I think I'd probably go with that. You know, obviously yours will look different, that's fine. And then they said 370, didn't they? So just be careful of the scale as well. Make sure the scale, you're reading it properly. So here, up. Oh, mine's come up quite nicely, actually. So I've got 14 exactly. Obviously, you're unlikely to get exactly the same as me, but that's fine. I'll show you what the range is in a minute. So I would write 14 in my case. And the range on the mark scheme is, yeah, kind of a big range. 12.8 to 14.8. So quite a big range. So as long as you're, you know, somewhere within that, you'll get the 2 mark. Obviously, just leave your line of best fit so they can see it. Yeah. So that's quite a nice one, I think. You got 14 as well. Yeah, nice. I think because I normally do these papers on like before as well, just so I can kind of know what's coming up. when I did it myself on a piece of paper, I got like 12. I got 14.2, so kind of similar. Okay, there is also a part C. So Alfie says, because there is an outlier, there is no correlation. Is Alfie correct? Obviously, you also have to give a reason for your answer. So you have to say yes or no, but also give a reason. So obviously, if we look back, you can clearly see that there is a correlation, even though you just ignore the outlier, right? But there is clearly a correlation because we've been able to draw a line of best fit as well. So there's multiple different ways you say it, as long as you obviously say no, or he is wrong, yeah, as long as you say that. They've given loads of options. Yeah, you can say exactly, there is positive correlation. That's basically one of their exact examples. They've said no, as this point can be disregarded from the general trend, or no, because you can ignore this point. As you've said, no, the correlation is positive, or there is positive correlation. No, because even an outlier, you can still see the positive correlation, or you can still have positive or negative correlation. No, because there is still a correlation. You don't even need to specify what type of correlation. No, as you can use the rest of the data to determine the correlation. No, as an outlier does not affect the majority. You know, they've literally given like 10 options. No, as a line of best fit can still be drawn. So as long as you've got something like that. Obviously, if you say yes, it's wrong. Okay. Just checking the comments just to make sure no one's got a question. Okay, perfect. So no, some kind of, you can still read the correlation. I just put there is positive correlation, so therefore that's obviously directly opposite to whatever he said. Okay, straight on to question 2. Because there's still a trend of data. Yeah, I think that's fine. Yeah, I think you could still say that. I think that would be okay. Yep. Okay, question 2. Natalie makes potato cakes in a restaurant. She mixes potato, cheese, and onion so that the weight of potato to the weight of cheese to the weight of onion is 9:2:1. So potato, cheese, onion. I just like to write the letters there. Natalie needs to make 6,000 grams of potato cakes. Cheese costs $2.25 for 175 grams. Work out the cost of the cheese needed to make 6,000 grams of potato cakes. So it's just kind of like a general arithmetic one, basically, isn't it? That's basically all it is. Just kind of dividing, timesing, multiplying, that kind of thing. So we've got here, okay, 6,000 grams of potato cakes. I'm going to share out the ratio straight away. So we're going to add that together, which gives us 12 parts. So 6,000 grams divided by the 12 parts. That should give you 500. Obviously, you can use the calculator because it's calculator paper, but that should give you 500. Okay. Then we've got, so 500 grams per part of the ratio. Now, we're focusing on the cheese, basically, aren't we? That's what we're focusing on. So the cheese is the middle one, which is 2 parts. So obviously, how much cheese do I need? 2 parts times 500 is obviously 1,000. So I need 1,000 grams of cheese, or like 1 kilo of cheese. Okay, I can move on from there. How much is that going to cost? So there's actually 2 ways of doing this because they didn't really specify. You know, when sometimes they specify that you have to buy it in the packs, as in packs of 175 grams. They haven't really specified that here. I assumed, but when I did it, that you had to stick with the fact that you can't just pick as much as you want. You have to choose 175 gram packs every time. That's what I did, but they do give you the correct mark. Like, you get all the marks for either option. So what I did was I said, right, how many packs will I need? So we've got 1,000 grams divided by the 175 packs. I'll show you that one because that one gave me obviously a decimal number. Get rid of that. 1,000 divided by 175. as you can see, it's like 5.7 packs. So I basically went with 6 packs of cheese. So I put 5.7 here. And then I said, right, I just assumed, yeah, I think you might have done it using the 5.7, right? Which is also fine. That's also fine. But I just assumed that you had to get 6 packs. Like you had to buy specific number of packs. I did 6. That's how I did it. But it will allow either. So I got 1350, which was correct. But as you've said, you got 1286, which is if you use this number here. Like if you use the 5.7, you know, ... number. So this is like an or situation. One of these 2 options, whichever, you know, made more sense to you. If I get my calculator, so let's say you use this number, times it by 2.25. That's the, yeah, 12.86. That's also fine. They said that you could get either, because they didn't really specify in the question, did they? So as long as you got either 1350 or 12.85 or 12.86, then they will give you the full marks for that. And that one was 4 marks. So yeah, that's just kind of just general maths, isn't it? Do you know what? I mean, we've seen this before. Even when the question said to round it, it still allowed you to not round it, didn't it? So I feel like it doesn't really matter in that sense. Yeah, I went with 6. Yeah, exactly. I went because it was like ... packs of cheese, and in my head I was like, yeah, but you can't just go into like Tesco and ask them for 0.7 of a pack of their cheese. You'd have to buy the whole pack. So I basically went with I just thought, oh, I'd have to therefore buy 6 packs in order to have enough. And that was 1350. But because they didn't really specify properly in the question, they have allowed in the mark scheme either using 6 packs as a whole number of packets of cheese, or literally just using the 5.7 as if you could literally ask for exactly how much cheese you wanted. They've allowed both. Okay. Yeah, so whichever of those you did is fine. It doesn't matter if you did it 1350 or 1286, it doesn't matter. They've allowed both. Because they didn't really specify in the question, didn't they? No, yeah. If you left it as 1285, let me see. The only reason why I would round it to 2 decimal places is because it is money. That was the reason why. I mean, mine came out exact anyway, but if you did it this way, I would have rounded it because it is money. The mark scheme says just 2 decimal places for each of them. It will allow 13.5 apparently, like that, if you didn't put the 0, which is odd, but let's see. Yeah, they haven't said anything about the long note. I honestly wouldn't be able to tell you, to be honest. I'll show you the mark scheme, look. Do you see here? That's all they've said. They've not even, if you look over here, there's nothing else here either. So I guess you'd have to round it. I don't know, because it's not wrong really, is it? I'm not sure. Yeah, I was expecting that they would know that, or you would know that you'd round it to 2 decimal places because of the context, but I don't know how fussy they are. They haven't said anything about anything more than 2 decimal places, have they? So I don't know. It doesn't really say in the question. They said they were allowed 1286 and 1285 and 1350. So any one of those 3. Yeah. Yeah. Okay, let's carry on. So question 3, you've got standard form. Write 4.5 times 10 to the power of 5 is an ordinary number. You can actually do this on the calculator, or you could obviously just work it out yourself. It's not really that hard, to be fair. You're basically just moving the decimal place 5 times, aren't you? But obviously make sure you know which direction. Because it's a positive power, it's gonna get bigger, isn't it? So 1, 2, 3, 4, 5. So you should have that many zeros. But you can also put it in I can show you how you put it in the calculator as well if you want. But the thing is with the calculator, I think it only works for the ones where it's like a positive power. So like you could put 4.5, and then my button's down here, yours might obviously be in a different place, times 10, and then you just put 5, don't put it as a power, just literally put 5 like that, and it will do it for you. You could do it like that. I don't know, because this is obviously an older calculator, I guess. I don't think it works for the negative powers. I think it's just for the positive ones, but at least that's half of it, isn't it? There's something there. So yeah, try and find that button on yours. But yeah, you should get, what's that, 450,000? 4 zeros. Then the next one's obviously the opposite. So again, I'll just count how many times you're moving the decimal place, which is 3, isn't it? So you have to make it 7 times 10, but because it's getting, the original number is smaller, isn't it? So it'd have to be a negative 3. When it's the negative power, you can just count the zeros if you want to. Yeah, if you've got a newer calculator, it might work with the negative numbers. Yeah. Yeah. Yeah, it's just figuring out how it works on each of your calculators. I mean, it's not, you know, massively complicated to work out anyway, is it? But you could double check it if you wanted to on your calculator. So yeah, that one should be 7 times 10 to the power minus 3. Then this one I would literally just type it in to the calculator, as in to work out. And then I think at the end you have to put it back into standard form yourself. But at least you don't have to do the literal calculation yourself. So times 10 cubed, and then plus 5.3 times 10 to the power of 2, or 10 squared. And then to see how it gives me the actual, so write this down, because it is 2 marks. You do need kind of like a middle step for the middle mark, if that makes sense, like the working out mark. So I wrote down this, that's my kind of first mark, and then for my answer, obviously convert it back into standard form. So that would be 4.73, and then we've moved the decimal place from here 1, 2, 3 times. And because the original number was bigger, it's a positive 3, isn't it? Yeah, make sure you have the correct calculator, because if it's too advanced, they might not let you have it. I don't know. You just have to, you know, as long as your teacher's happy with the calculator, you'll be alright. Yeah. So yeah, bit of standard form there. I think you did get standard form on paper 1, didn't you, though? So I feel like, I don't know if it would really come up again. Alright, question 4. So a water tank is empty. Anil needs to fill the tank with 2,400 litres of water. Company A supplies water at a rate of 8 litres in 1 minute 40 seconds, and Company B supplies water at a rate of 2.2 gallons per minute. They've obviously given you the conversion between gallons and litres, because they won't make you convert between metric and imperial. Company A would take more time to fill the tank than Company B would take to fill the tank, so how much more time? So basically work out both, and then from there, find the difference. So we've got Company A. So I think there's like, obviously again, different ways to kind of go about this. They've given in the mark scheme like 3 different kind of methods to do it. So you might have done it in a different way to me. That's fine, as long as we get the same answer at the end. But what I was thinking was, I was going, okay, well, how many 8 litres is in 2,400? That's what I did for Company A. This is divide by 8, so that should be 300. So that's 300 lots of 8 litres, isn't it? 300 lots of 1 minute 40. So then I worked out, well, how much time is that in minutes? So 300 times 1 minute 40, which obviously I converted that into minutes anyway. So, I mean, anyway, you might know, obviously 40 seconds is 2/3 anyways, and it's 1 2/3, but if you don't, you can obviously just divide by 60, or, well, yeah, let's make it, that's 100 seconds, isn't it? You could divide that by 60, or you could divide 40 by 60 and add the 1. So we've got either 5/3 or 1 2/3, as you can see. That's how many minutes it is, isn't it? And then times that by 300. So I got 500 minutes. So Company A would take 500 minutes. That's what I got. Then for Company B, we have to obviously do a conversion. So what did I think to do? You can obviously convert either way. I think I converted the 2,400 into gallons. I guess you could do it the other way around if you wanted. This is A, isn't it? So I did 2,400 and I divided it by the conversion, which is 4.54. That's what I did. But again, you might do it in a different order, that's fine. So 2,400 divided by 4.54. And that gave me, as you can see, 528 ... gallons. So that's actually how many there is in total. Obviously, ... And then it says there's 2.2 gallons per minute. So I then just divided that again by 2.2. So what was it, 500? I'm going to keep obviously all my decimals from my calculator. I just wrote down 1 though. So use your answer button where you can. So answer divided by 2.2. So that gave me 240 minutes, 0.28. You can see that. 240 minutes, 0.288 ... So that's B, isn't it? We've got there and there. And then it said, well, how much more time did it take? So obviously now you just find the difference. Don't forget at the end to find the difference. 500 minus 240. Minus, I'm just minusing my answer. So I got 259.7, but they did say give your answer in minutes correct to the nearest minute. So that's obviously 260. That's what it rounds to. They have said anything between 259 and 260, so that's what we were saying about rounding, wasn't it? Even if you didn't round it, if you wrote down, because what was my answer? If you wrote down literally 259.71 whatever, I think they'd still give it to you. Let me just check. I just made this one into gallons, because ultimately at the end we're looking for minutes, aren't we? So we're not necessarily having to compare the litres or the gallons. Oh, times it by times. You got 8 hours and 20 minutes. Hang on, yeah. Let me just see what that would be. Yeah, that would be 500 minutes. 8 hours and 20 minutes is correct. It's 500 minutes. The only reason why I left it as minutes and not hours is because they said give your answer in minutes. That was the only reason. Yeah. So you are correct. It is 8 hours and 20 minutes. Just make sure that at the end you do give your answer in terms of minutes. We can go back. As I said, there's different ways to do it. So maybe my way of doing it doesn't really make logical sense to you guys. That's the thing. Yeah, they've given like 3 different options of what you can do. Is it just the B bit that's confusing? Does the A bit make sense? Or is it all of it that you want me to go through again? Just want to make sure I know which bit to look at. If you mean all of it, that's fine. But if it's just the B bit, then we'll just look at the B bit. The whole question, yeah. So, okay. So either way, for both, it's kind of like a nil is deciding, do I go with company A or company B, isn't it? It's like 2 options. Either way, we've got 2,400 litres of water, right, that needs to fill the tank. So either way, we're starting with that same amount. So you can see here, that's why I started with the same amount. So for company A, they're saying that every minute and 40 seconds, they will fill the tank with 8 litres effectively. Like 8 litres goes in every minute and 40 seconds, isn't it? So I want to find out, because the question is in terms of time, isn't it? The actual question is asking how long it takes. I just want to work out how long would that take then in total. So I did 2,400 litres divided by 8, and that gave me the 300. Right, so that's basically 300 lots of 8 litres, isn't it? 300 lots of 8 litres. And every 8 litres, it's a minute and 40 seconds. So that's why it was 300 lots of 1 minute 40. So that's that bit. And I obviously converted it to decimal in my calculator. You got 8 hours, 20 minutes, which is also correct. The only thing is at the end, they do want it in minutes. So if you do hours, that's okay until the end. Make sure at the end you do put it in minutes. So I got 500 minutes just because I was leaving it in terms of minutes. That's obviously the seconds, isn't it? 1 minute, 40 seconds. So does that bit, like, does the 500 make sense so far? And then I think it's more so company B that's more confusing, because they've also got this conversion. I feel like for company B, the time is easier because it's just per minute, but the volume, I guess, is more difficult, isn't it? Final answer, you got 8 hours, 4 minutes. Yeah, that doesn't sound quite right. But you said 8 hours, 20 minutes, so you must have got part A, as in, when I say part A, I mean company A. You must have got up to this point fine, because that was also the equivalent of 500 minutes. I think maybe it's just part B that wasn't. So for company B, it's a rate of 2.2 gallons per minute, which is obviously a different version of volume, isn't it? So they gave us that conversion. Now, what you kind of have two options, I guess. What I did was I took the total. Obviously, either way, we're starting. It's kind of like two different sections here. We're starting with 2,400 litres either way. I converted the total litres into gallons for the whole tank. That's what I did. So the total tank is 528.6 ... gallons. That's what I did. You could, I guess. Can we still see that? Let me just check. Yeah, up here, you could, if you wanted, convert, I guess, the 2.2 gallons into litres here. You could convert that bit if you wanted to. To me, it just didn't really make sense to do that, so I just didn't. But it depends what makes sense to you, doesn't it? That's the thing. Like, they've got different methods in the mark scheme, because for everyone it's going to make sense in a different way. Okay, I think, give me a second, guys. I'm just going to remove this guy, because he's just distracting everyone. Okay, yeah, I think that might have removed him. We'll see. Okay, yeah, so that's what I did. I just converted that. So the total tank has 528 gallons, obviously with decimals. And then it says, well, they're going to fill it with 2.2 gallons per minute. So I just said, well, total gallons divided by 2.2. Now, it's kind of the same as what I did up here. Obviously, here I had to times by 1 minute 40. The reason why I didn't have to times by 1 minute here is because obviously times something by 1, it's still the same answer, isn't it? So I didn't need to do that here. So it was just 240 minutes, or you might have got that in hours, I guess. What's that, like about 4 hours something? 4 hours point something, but I would leave it in minutes ideally. And then the last thing, here's like the last section, let me scroll up again, is because they said, how much more time does it take? It's just the difference. Yeah, this paper is the November 2021 paper 3, Edexcel higher tier, but it's in the title. Yeah, thanks guys. Let me just check the comments. The time function in the calculator, I think that just converts hours into minutes, doesn't it? Like, let's say if I put 1.5, I don't know if this is the one you're talking about, this one here, it gives me 1 hour 30 minutes, or if I had seconds as well. I don't think it works the other way round. I mean, maybe your calculator is obviously, again, more advanced than mine, maybe it does, but maybe that's why it went wrong. Just times it by 60, I guess, and then, yeah, I'm just gonna, sorry, I was checking up with the comments. Oh, well, I kicked him out and he's come back, so I'm gonna have to. Doesn't give me an option to block, so we'll just have to do a timeout. There we go. All right. So the difference is 260 minutes, because one of them was 500 minutes, one was 240, so the difference is obviously then 260. Is that okay for everyone? To get from 8 to 2,000, you multiply by, yeah, exactly. You multiply by the 300. You did 4.54. Yeah. That's what I was saying. You could convert the 2.2 into not minutes, into liters, couldn't you? You could do it that way as well. That's also fine. Yeah, 2.2 times, let's see, and then 2,400 divided by that, what does that give? It gives you the same answer, doesn't it? You get 240.2. Yeah, that would be fine as well. Yeah, Yeah, you should have got the same answer then. The 200. Hang on, let me show you on the calculator here. So you're saying that you did 2.2 times the 4.54. So that gave you 9.988, which means litres, doesn't it? Litres per minute. And then you did therefore 2,400 divided by that answer, the 9.9. You see how you've got the same answer as me? Let me scroll down so you can see it. Do you see how I got 240 as well? You should have got the same answer, yeah. In minutes at least. Yeah. So if you got the 500 as well, because I know you said you got 8 hours 20 minutes, which is the same as 500 minutes, and then you've just done this, which you should have got 240 minutes. They're both in minutes. So the last thing is, because they said how much more time does it take for A than B, is just the difference, isn't it? So do you see how I just subtracted them, like 500 minus the 240 answer, which gave me 259, but obviously because they said give it to the nearest minute, I rounded it to 260. But they have said they will accept, even if you wrote all of these decimals, they will give it to you as well. I don't know where you got 20 from, yeah, because when I calculated it on my calculator, you just saw it came up with the same answer. So your steps were correct, maybe just something in the calculator went wrong. Yeah. Yeah, you got the right time for A, that's the thing. You did the right steps for B, but for some reason in the calculator it came out wrong. So I don't know what happened there. But like your actual steps were correct. Like your logic was correct. So I don't know, it was obviously just the calculator that something went wrong. You did subtract using the time function, but you don't really need to use the time function, I guess. I don't know. And I guess because you had it in hours before, maybe. Yeah, it must have just been that last little bit, because you've done all the kind of major pieces correctly, if that makes sense. It was just the last bit that didn't translate properly. Yeah, it might have been that. Maybe the function didn't work properly. But yeah, as long as that kind of makes sense. But as I said, you can do it in different ways. As long as you end up with 260 at the end, then that's fine. Question 5, we've got the first 4 terms of a Fibonacci sequence are A, 2A, 3A, and 5A. The sum of the first 5 terms of this sequence is 228. Work out the value of A, so we need to create basically an equation. I didn't round the time to 240, I just rounded the last number. Like I did 500 minus 240 point whatever it was. 0.2, point something like that, and then at the end I rounded it. Oh, because it's 240 minutes, not 240 hours. 240 minutes. So Fibonacci sequence, all we need to know is that the way that works is when you add the previous 2 together. So you see how you've got A plus 2A is 3A, and then 2A plus 3A is 5A. So every time you're just adding the previous 2. So they've said the first 5 terms, we've obviously only got 4 terms here. So the first thing is I need to work out the 5th term, which is obviously these 2 added. Draw that a bit more straight. Yeah, those 2 added. And then that gives me 8A. And then I just create an equation, basically. It's A plus, because they said the sum means plus, doesn't it? 2A plus 3A plus 5A plus 8A. And then that is equal to 228. And then there, it's just basically an equation, isn't it? So if you add them together, I think, what do we get? That's 10 plus 8, 19? I think it adds up to 19A, yeah. So you get 19, that's not a 9, that's a 2. 19A is 228, and then obviously there, it's just an equation, isn't it? You divide by 19. 228 divided by 19 is 12. So yeah. As long as you know what Fibonacci sequences are, that's fairly easy, but yeah, you just have to remember what they are. You just add the 2 previous ones together. Yeah, it's really easy algebra as long as you know the starting point. It's quite hard if you've forgotten what a Fibonacci sequence is. Okay, question 6. So, in a bag, there are only red counters, blue counters, green counters, and pink counters. The counter is going to be taken at random from the bag. The table shows the probabilities of taking a red counter or a blue counter. So you can see, obviously those are the ones they filled in. The probability of taking a green counter is 0.2 more than the probability of taking a pink counter. Now, again, different ways to do it, but normally with these ones, I just say, like, whichever one is the smallest, I put as x, and then the other one, in this case, would be x plus 0.2, and I just work it out that way. You might have worked it out a more direct way, that's fine. So I just said, yeah, this one is the smaller one, isn't it? And then I said, well, that one has to be x plus 0.2, and then you can figure it out from there, because they all have to add up to 1, don't they? So I just basically did that. I said, these two added together, that's 0.2, isn't it? Plus x plus 0.2 plus the other x is 1. And then you can see kind of from there where to go. If you want to do algebra, you can do it this way. You can obviously do it other ways if you don't want to use algebra. So x is 0.3, obviously, therefore the pink is 0.3, but then there's the green is obviously 0.5. So there's that. Then there was part B. There are 18 blue counters in the bags. They've actually given us how many there are. Work out the total number of counters in the bag. So 18 is effectively, if you think about it, it's 15%, 0.15. Again, you don't have to use algebra, but just to show you, let's say that y is the total. I'm not going to use x because I've already used x. And then you can see all I need to do is just divide. Again, you don't have to write that down, but just so you can see that's where it comes from, I'm going to do 18 divided by the 0.15. So it's just like reverse percentages, I guess, or reverse decimals, if you want to call it that. 0.15, 120 you should get for the total. Because the reason why we do it is this kind of here. Imagine you're doing it the correct kind of way around. Imagine, let's say that you did know what the total was. So if they said the total is 120, 0.1, the probability of getting blue is 0.15. How many blue are there? Imagine doing it that like the correct way. I feel like you would kind of naturally go, yeah, I take 120, I multiply it by the probability, and it gives me 18. So that was the original kind of calculation. That's originally what happened. We're trying to kind of work backwards, aren't we? So that's why I wrote this down. It's kind of like 18 is equal to 0.15 times by the total. So then to find the total, I need to do 18 divided by 0.15. Okay, so that's why. So it should be 120. Question 7, we've obviously now got some kind of area type question. So the diagram shows a sector OPQR of a circle, center O, and the radius is 8. So OPR is obviously also a triangle. You can see we've got a right angle there. Work out the area of the shaded segment, PQR. So when we want to work out a segment, you always work out the whole sector and then the whole triangle and then just subtract them, right? It's like a kind of cutout situation. So just we need those two areas. We need the area of the sector, that thing, that's meant to be a sector, which is obviously pi r squared, which is 8 in this case, pi times 8 squared, but we've only got a quarter of the whole circle because it's a right angle, isn't it? So I would divide that by 4. So normally I leave it in terms of pi until the end. So you've got 64 divided by 4, which is, that's basically 16 pi, isn't it? And then the area of just the triangle is obviously base times height over 2, or half base times height, whichever you prefer, which is 8 times 8 over 2, which again we said 64 over 2 is 32. And then we subtract them now is obviously when I would then work out the decimals. So calculator, 16 pi minus 32. Now they said 3 significant figures, and that's 18.3. 18.3. I think that's quite nice 4 marks, that one. Again, I think in the mark scheme they don't really care if you round it in the end, which seems kind of pointless for them to ask you to round it if they're not going to be that bothered. But they have said anything between 18.2 to 18.3. Because it says even if you've rounded it incorrectly, but as long as you're within that range, they will still give you the full marks. So Technically, you don't need to round it, but I obviously just would anyway, just in case. Question 8. We've got some graphs here now with proportion. So part A, using the axes below, sketch a graph to represent the statement y is directly proportional to x. So just think of it, when we normally do proportion, I normally use a formula. The formula for direct proportion is it's meant to be equal to kx, isn't it? Hopefully you recognize that formula. Try and forget about proportion now. Just think of this, what type of graph is that? K represents a number, doesn't it? It doesn't really matter what the number is, but it represents a number. So that's just a linear graph, isn't it? That's just a straight line graph. That's effectively the same as y equals mx plus c, isn't it? It's the same thing. So for direct proportion, you can also just memorize it. It's a straight line graph. So what I would do, obviously get your straight line. And do you see how there's kind of no plus c? It's technically 0. So starting from 0, 0, just draw like, I don't know, something like that. Just straight line going through it. Obviously, we don't know what the gradient is, but, you know, just a straight line like that, starting at 0, 0. That's it. So just think of it, if you're not sure what the answer is, if you don't remember, just think what was the actual formula for direct proportion. And the same logic here. So using the axes below, sketch a graph to represent the statement y is inversely proportional to x. So the equation for inverse proportion is k over x, which again, k represents a number. So imagine that that number is 1. Because it could be. What graph is that? This is just a reciprocal graph. Now, we've only got one quadrant. I know normally the reciprocal graph is like this, isn't it? There's one down here. We only have one quadrant, so just draw the top one. So this one would be, oh, that was really bad, but something like that, basically. Try and make it look like, try and make it look like a reciprocal graph as best you can. Okay, so direct proportion is just like a straight line graph from 0, 0. Inverse proportion is a reciprocal graph. Question 9. This is what I would call worded inverse proportion, actually. I know they don't mention that in the question, but that is effectively the topic. So on Monday, 12 people took 5 hours to clean a number of cars. On Tuesday, 15 people cleaned the same number of cars. Assuming that all the people worked at the same rate, work out how many hours the 15 people took to clean the car. So it's inverse because if you think about it, the more people I have, the less time it will take, or the less people I have, the more time it will take. It's inverse. So I normally work out how many hours it takes for one person. Now, naturally, I feel like you'd want to do 5 divided by 12, but it's not, is it? It's inverse. So you do, if I have only one person, it's going to take 12 times as long, isn't it? So that'd be 60 hours. You can do this all in one calculation if you want. So that's for one person, but I've actually got 15 people. So 15 people is going to be 15 times faster. So then I would divide it. I feel like naturally you want to divide first, then times, but it's because it's inverse, you do the opposite. So obviously 15 people should technically take a little bit less time, shouldn't it? So that's 4 hours. And then part B, the assumption is wrong. You still see the assumption? Yeah, just about. So the assumption was that the people worked at the same rate. They're saying the assumption is wrong. They don't work at the same rate. How might this affect the time taken for the 15 people to clean the cars? Well, it's only saying that they don't work at the same rate. What we don't know is, does that mean they're faster or slower? We don't know. So you can say, how might this affect the time taken? It could take more or less time. We don't know. More or less time. We actually don't know, because even though they've said they don't work at the same rate, we don't know if they're all like some of them are faster, some of them are much slower, we don't know. They have said acceptable answers. Obviously this one, you could say it could take more or less time. They will also accept you saying just it will take more time or it will take less time. You could say just one of those two things. Anything like that. But effectively we don't really know, do we, if it's going to take more or less time, but it will change the amount of time, won't it? Question 10, the diagram shows 2 right-angled triangles, ACB and DEB. They've given us some of the measurements, and they say calculate the length of CB, so the whole of the base. Now, because they haven't mentioned it, have they? But because these triangles overlap, it means that they're similar, aren't they? They both come from point B and they're kind of stretched outwards, obviously at a different scale factor. So what have we got? We've got AD is 9, so just that bit. DE, what's that here, is 2, and DB is 6. So I want to basically work out the scale factor. Now I've been given enough information to work out, obviously I've got DB, but also I could find the side AB. So don't just use the 9 because the 9 isn't a whole side, is it? It's just part of a side. So AB is 9 plus 6, which is 15. So the whole side, AB is 15. So all we need to do then is, scale factor, you can divide them either way round. I like to do the bigger number divided by the smaller one, just because I feel like the answer is always nicer. I don't know, that's just my preference. You don't have to do it that way. You could also do 6 divided by 15 if you wanted. So in my case, I found out that triangle ABC is 2.5 times the size of triangle, what was it, DEB? So there's that. I then use that because I don't have any kind of base numbers, so I can't just use that directly. What I can do is use that to work out AC, because I know DE, and those match, don't they? So AC, in my case, because I worked out that it's 2.5 times as big, I'm going to multiply it. If you did it the other way around, I guess you would divide. So it doesn't really matter as long as you end up with the same answer. For AC, yeah, we get 5. So this is 5. Now, because we don't have any information about the base side, like the bottom side, what I would do from here is I personally just use Pythagoras. To be honest, I forgot about the whole situation of similar triangles and I just went, right, this is Pythagoras. So that's 5. I'm only just redrawing it so we don't get mixed up with the 9 and the 6. This is 15, isn't it? So you see how we could work out, this one is CB. So because we've got the hypotenuse, that's squared, isn't it? Plus 5 squared plus CB squared. You can obviously rearrange it straight away if you want, but effectively what we'd need to do is the square root of 15 squared minus 5 squared. Just be careful there, not plus, minus. So square root 15 squared minus 5 squared. And then it says to 2 decimal places. So 14.14 is what I got. 14.14. And again, they have said anything between 14.1 to 14.15. Again, if you don't round it correctly, they will still give you the answer as long as obviously it falls within this range. They will still give you the correct, well, like all the marks. They'll still give you full marks even if you don't round it. So yeah, that's odd. So yeah, that was kind of a mixture, that one, I guess. Similar shapes and also a bit of Pythagoras if you wanted to do that. I've seen error interval come up quite a lot on paper 2, maybe also paper 3 obviously, but the calculator ones. So Freya writes down the value of x correct to 1 decimal place. She writes that x is equal to 6.4, complete the error interval for x. It's 2 marks, but effectively it's just 1 mark for each number. So, I don't know, sometimes they give you less space than this. For some reason they've given us loads of space here. You don't obviously really need it, you can just put your answer straight. When it's rounded correct to 1 decimal place or to the nearest whole number, it's like rounded. It's obviously the same as upper and lower bounds, isn't it? So you want half a decimal place below and half above. What I mean by that is obviously 6.35 and then 6.45. You don't even need any working out. Yeah, exactly. 6.35, 6.45. You get a mark for each of the numbers, but obviously in the correct position as well. So yeah, that's nice. Question 12, we've now got an indices question. So work out the value of A and the value of N. Because you've got 2 letters, you effectively need 2 separate equations, right? It's kind of loosely around simultaneous equations. You can't solve an equation if you have 2 letters in it, right? You need more than 1 equation. So we're going to split this in the end. But what I did was I first kind of expanded these brackets, and what I mean by that is applying the index law when you've got the brackets. That's when you have to multiply the powers, isn't it? So just be careful because you've got an A and an X in there. So if I were to multiply the powers, technically the a is currently to the power of 1, isn't it? So do you see how that would become a to the power of 1 over n, because I'm multiplying the powers? That would be what, 230 to two significant figures? Obviously keep putting the, like, it can't be 23 because that's not the same number. I would put 230 for that answer. So it's still the same scale, but it obviously rounds down, doesn't it, to 230. Anyway, so then I would multiply powers, so that's a to the power of 1 over n. It's not a multiplied by that, right? It's the powers. And then the same with the x, the 6 times 1 over n is effectively 6 over n, isn't it? And that's how we multiply fractions. So I do that first. And then when I was saying about having two different kind of equations, I would separate them. So do you see how the a is obviously the coefficient, and this is also the coefficient? And then the x term is obviously the same as the other x term, isn't it? So I just split it like that. So I said, right, a to the power of 1 over n is equal to 7. Now that one does still have both letters, so I can't really do anything with that right now. But let's look at the x. I've got x to the power of 6 over n is equal to x to the power of 3. So therefore, I can just look at the powers. They must be the same. And then you see how you can just rearrange that. So you should get n is 2. So that's that one. And then once you know n, you can obviously then go, okay, well that's a to the power of a half. What does that mean? Well, the power of a half means square root. So to see how I could reverse this, a is then 49. 7 squared is 49. Oh, well, they couldn't give you that question because it's not been rounded to two significant figures. Like the number you've given us isn't rounded to two significant figures, so that wouldn't be the question, if that makes sense. Like their question for your example would be 230 was rounded to two significant figures, write down the error interval. That's what the question would be. Truncated is where you just cut off the numbers. It's like, if I come back here, because they could ask this question, which was the rounded version, wasn't it? Was correct to 1 decimal place. They also could use the word truncated or truncate. And that is where, let's say if they truncated it to 1 decimal place, that means they did 6.4 and they cut off whatever came after. Yeah. So it could have been a 9. We don't know. It could have been a 1. It could have been 0. We don't know what came after it. We just know that they looked at the 6, they looked at the 4, and then they cut off whatever came after it. They did not round it up or down. They just cut it off. So yeah, you have to be aware of the two different types of error interval questions. It's either truncated or rounded. When it's rounded, like the one we've just done, it's the same as upper and lower bounds, isn't it? But when it's truncated, it works slightly differently. It's also the example, I don't know if you've seen where they say that they read off a number from their calculator display and they said the number started with this and this and whatever it was. That's the same as truncating. Yeah. Okay. So question 13, I feel like there's always some kind of coordinate problems, whether it's something like this, which is really random, or whether it's like find the midpoint, find the distance between the coordinates. You know what I mean? Like just general kind of coordinate problems. That comes up quite a lot. So we've got 13. A pattern is made from 4 identical rectangles. The sides of the rectangles are parallel to the axes. So it's not like slanted, it's literally horizontal and vertical. You can obviously see we've got point A and point B, and point C has been marked here. We're going to have to work out the coordinates of point C. I don't know, I just called it coordinate problems. That's what I called it. That's quite vague, I realise. Yeah. Okay, so how did I go about working this out? I went about working this out by using algebra, I think. Looking at the mark scheme, I think you do have to use algebra, actually. Yeah, the way that I did it was using algebra. So what I did was I labelled all of the kind of long sides with one letter and all the short sides with a different letter. You can use X and Y. That might get confusing with the axes, I guess. Or you can use like A and B, whatever letters you want to use. So maybe I'll go with A and B just so we don't get mixed up with the coordinate X and Y. So for example, like this one, let's say the long sides are A. It's like that's A. Do you know what I mean? Like the long sides are all A. And then let's call the short sides B. Things like that. These are kind of B ones. Anyway, so what I'm going to do is create some equations. Because again, we've got 2 letters, you need 2 equations. Obviously, we're going to do one for X as in horizontally, and then one for Y vertically. Because we have a starting point A and starting point B here. So let's look horizontally. So across the distance between A and B, do you see how we've got 1A here? This one goes too far, but the difference is the short side, isn't it? So the way that I wrote that one out was I said, right, that's A plus A minus B. Do you see what I mean? To kind of cut off this extra piece here. And that equals to, in terms of the, I keep moving that thing, in terms of the X coordinates, the distance between 3 and 11. So the distance between 3 and 11 is 8, isn't it? So you see how I could write that equals to 8? That's like, yeah, make simultaneous equations, exactly. So you can write that as 2A minus B is 8. That's one of them. And then I did the same but vertically. So let's use orange. So vertically, let's see. Vertically, we've got obviously an A, another A, and also a B. So it's all plus, isn't it, this one? So vertically, you've got A plus B, yeah. And then vertically, that would equal the distance between 4 and 20, which is 16. So you see how that would be 2A plus B, which is 16. And luckily, these are really nice simultaneous equations. These two. Yeah. Whenever you've got 2 things you don't know, it's normally some format of simultaneous equations. That's the thing. Or if you've got 3 things you don't know, you might need 3 equations. You know what I mean? So just looking at these, they're linear simultaneous equations. So it's either elimination method or substitution. I'd probably just eliminate them because you've got the same amount. Well, either the same amount of A's or the same amount of B's, actually, looking at it. I think I got rid of the B's, but actually you probably could just get rid of the A's, couldn't you? Yeah, I'm just going to get rid of the B's. That makes more sense to me. But you can get rid of whichever one you want first. Different sign, add. So I need to add the 2 equations. So that gave me 4A. Obviously, those cancel. And then add that as 24. So you see how I can work out A is 6. Now, the only thing is that's obviously not the coordinate, isn't it? So 2A plus B equals 16. This one here. It's come from I've probably write them in the same place. Let me write them in the same place. Kind of not written it in a very good order, have I? So for the x-axis, it was A plus A minus B is 8, wasn't it? And then for the y-axis, it was A plus B is 16. And then I simplified, collected the like terms and got these. I don't know which part of that you're not sure about. Look, if you look at, I've tried to obviously color code it as much as I can. You're talking about the y one. Do you see how, because y is vertically, isn't it? Do you see how that's A, that's a whole side A, and then there's a B. So I got A plus B, which makes 2A plus B. And then the 16 came from the 20 and the 4. Do you see how the literal difference is 16? That's where that came from. Yeah, I don't know if that answers your question. Same for the x, I did the same, but just obviously horizontally. So we've got A is 6, and then if we just quickly work out B, and then we can look at the coordinates. So obviously once you've worked out, think about simultaneous equations, once you've worked out one of them, you just sub them back in, don't you? So you can sub it into whichever of the equations you like. I think I'll sub it into the second one, because why not? So 2 times 6 plus B is 16. 2 times 6 is obviously 12. So then B is 4. So I've got A and B. Remember now that I labelled A as the long side and B as the short side, didn't I? So just remember what those relate to. You might have used different letters than I did, that's fine. The only thing now is we need to work out the actual coordinates of C. Like 6 and 4 are not the coordinates, are they? They're just the distances. So for C, I started from A and I said to get from A to C across, do you see how that's just one long side? Obviously, we are starting at 3, and then we're going to add A, which is 6. So you see how the coordinate, what was it, C, is 3 plus 6 for x, and then for y, obviously I'll add that together in a minute. To get from A to C vertically, it's just a short side, isn't it? Just up, short side. Now, A obviously does start at 4 in terms of a height, starts at 4, and then the short side was also 4, so you add that. Does that make sense? So then the actual answer, obviously you add them, is 9, 8. Yeah, 9, 8, exactly. That's how I figured it out. You might, as I said, you might have used different letters, that's fine. As long as you got to 9 and 8 at the end, then that's okay. But it is quite a specific question, that one. Like, it's one of those ones where I don't think they'd literally repeat the exact same question, if that makes sense. It's quite a specific one, isn't it? So, like, my point is, I don't think it matters if it doesn't fully make sense, because it's not one of those ones that's, like, super repeated itself. How many marks was it? 5. Oh, you think it should be 6? Well, the way they've distributed the marks is you get 1 mark for setting up the first equation, so whichever of the two. Obviously, then you get the second mark for setting up the second equation. You then get only 1 mark for working out A and B. So yeah, maybe there you might want some more marks. Your 4th mark is for obviously then finding one of the coordinates of C, and then your 5th mark is for finding both coordinates. Yeah. It's quite a weird one, that one. I don't know. It's a bit of a hit or miss question, I think, that. But yeah, like I said, I don't think they would repeat that one very specifically. Like, I've not seen one that's exactly the same as that before. Yeah, I've seen the 6 mark question, not like loads, but I've definitely seen like the odd, here and there, the odd 6 marker. Yeah. Not always, but just, yeah, most of the time 5 is the highest. I think 5 is the most common, but I have seen where maybe one of them, like, there's one question where it's a 6 marker. But just, yeah, like a whole question. It is possible, it's just not that common, if that makes sense. Obviously, most likely to be at the end of the paper, isn't it? So, question 14, we've got Olivia and Jessica have in total half as many sweets as Fran and Gary have in total. So, Olivia and Jessica have half of the sweets that Fran and Gary have. Fran and Gary share their sweets in the ratio 2 to 3. So, I don't know, I just like to write it out like this. Fran and Gary, 2 to 3. Olivia and Jessica share their sweets in the ratio of 9 to 1. They've then said Fran got W sweets, Gary got X sweets, Olivia got Y sweets, Jessica got Z sweets, you get the gist. Basically, find in its simplest form the ratio of all of them together. So, they actually give you loads of working out space for this, but I feel like it wasn't really a lot of working out, to be honest. What I did was I added them together and I said, right, because they're talking in the first sentence about the total of each of them together, isn't it? So, for example, Fran and Gary in total have 5 parts, not literally 5 sweets, but some multiple of 5 sweets, isn't it? And Olivia and Jessica have 10 in total, so hopefully that kind of makes a link. Obviously, one is a multiple of the other. However, they've then said, so you obviously want to get them to be the same scale, don't we, before we can combine them. Now, I feel like you naturally just want to double Fran and Gary's, but it's not just that, because in this case, Olivia and Jessica have in total half as many sweets. So 10 is half of the amount of Fran and Gary, right? It's half. So Fran and Gary, actually, if you double this, I don't really know how to write down the working out, to be honest. Fran and Gary is 2 lots of 10, isn't it? Which is 20. So you see how I'd actually, to go from 5 to 20, I'd actually have to multiply Fran and Gary's by 4 to get the same scale. So you just multiply each of those by 4, so obviously that's 8. That one is 12, which adds up to 20. And then you just put it in the ratio, in this, you know, to make sure you get in the right order. Fran to Gary to Olivia to Jessica. That's your ratio. I don't know, it's kind of hard to write down the working out for it, to be honest. But you get marks for writing down 2 plus 3 is 5, 9 plus 1 is 10. Like, you literally get 1 mark for that. You have to write both, 5 and 10. You can also choose numbers as well. If you wanted to put one of them as 100 and one of them as 50, you could do that as well. They've allowed that. And then your second mark is for finding the relationship, as in multiplying by 4. And then your third mark is for literally multiplying the 2 and the 3 by 4. And then obviously your final mark is for the simplified ratio. Luckily, because I did it this way, I didn't have to simplify it. If you'd assigned numbers, like maybe 150 and so on, then you might have had to simplify it. Yeah, I don't know. It's almost like it's not hard, but it is hard to get your head round. That's the problem. Like the actual maths isn't that hard, but trying to get your head round the link between them, I think it's kind of a little bit trickier. Yeah, that one was 4 marks, so not really a lot of actual writing down for 4 marks. Yeah, I think that one I found it quite just quite hard to get my head around it. You know what I mean? That was maybe I would have assigned numbers. I guess if I was in the exam, I probably would have assigned actual numbers and tried to then visualize it that way. Yeah, but it's hard to get your head around. I feel like. Hang on. Yeah. Let me go back. I could maybe do it with the numbers. That might make more sense, I guess. Let me show you if I were to assign numbers. This is one way of doing it, which I know is not really written down very officially, but still. So let's just say that Fran and Gary, let's say they have 100 sweets. I know they don't, but let's just say they have 100 sweets. That would mean that Olivia and Jessica would have 50, wouldn't it? Because they have half. And then you could actually share them out, literally, couldn't you? Right? Because you could say, right, Fran and Gary's 2 to 3, so let's share that out. Obviously, we add that up. Makes 5. So 100 divided by 5 is 20. So then Fran would have 40, wouldn't she? Gary would have 60. And then if you shared out the other one, 10. Do you see how if I do... Let me move this over a bit. What was it? 50 divided by 10 is obviously 5. There. And then 5 times 9 is... who's that for? That's Olivia. I'll lay it out the same way. Olivia to Jess. 5 times 9 for Olivia would be 45, and obviously Jess would be 5. And then, because it's in the same scale, you could put them, obviously that would be 40 to 60 to 45 to 5, but you then have to simplify it, which you can see they all do divide by 5, don't they? So that'd be 1, 9, 12, and then 8. So you could do it that way if you wanted. Like this is, oh, that was horrible. You could do it that way if you want, if that makes more sense. That might make more sense to put some actual numbers to it. And again, you know when I say put numbers to it, you can choose, I normally choose 100 to start with and then go from there. So yeah, either one of those versions, but you should get the answer there. Yeah. Question 15. I'm pretty sure you already got this in your paper 1, so I highly doubt they're going to ask it a second time, to be honest, but we'll go through it anyway. So question 15, the graph gives the volume of water in litres in a container at time t seconds after the water started to flow out of the container. So using the graph, work out an estimate for the rate at which the water is flowing out of the container when t is 12. This is obviously the tangent one, isn't it? Yeah, this is the tangent question, which I think you've already been asked, isn't it? I'm pretty sure this came up on paper 1. You guys can correct me, but I'm pretty sure it did. And you also had the area under the graph as well. So that, I doubt, would come up again. It's quite a specific question, those two, isn't it? So yeah, it's the one with the tangent where you find the gradient. Whenever you see rate, so it's some kind of gradient, isn't it? Now, before I draw my tangent, what I like to do, because you obviously have to have 2 sets of coordinates, isn't it? Is I like to use the actual t, as in this case is 12. Just be careful of the scale. 17, just because I know that that's an exact coordinate, and then my tangent, which might not be like that accurate, at least I've got one set of coordinates that's accurate, but again, I mean, you've already done it, so it doesn't really matter. So at 12, where's that there? Let's just try and draw my tangent. I don't know, maybe something like that. And then I would just pick another set of coordinates because I've already used the 12 coordinates. So what's another, this is quite a nice set of coordinates here. What's that, 5? I think I would use 5, what was that, 23? That's what I'm going to use. You can obviously use whichever stands out to you. And then you would just find the gradient, isn't it? Yeah, it should be a negative one. As you can see, it's going down, isn't it? It should be a negative gradient. So gradient is change in y, so that one over the change in x. Yeah, you can see it's going to come out negative. What was that? 6 over minus 7, that's what I got. Which we'll get as a decimal. So I got negative 0.86. Negative. Now they did give a range, obviously. They said anything between, well, I guess it's, well, I guess the gradient's negative, but anything from 0.7 to 1.1, because I guess, well, the gradient's negative, but I guess in this case it's not negative in the context. You got 16 out of 17, what's that? Let me find that as a decimal. Sounds okay. 0.94, that would be fine. Yep, that would be fine. I think on when I actually draw on a piece of paper, I got literally 1, so that's also within it. Yeah, exactly. That would be fine. But as I said, I don't think they're going to ask you this again because you've already done it, haven't you? So, yeah. What have we got? Done that one there. Question 16. Oh, this is a nice one. Because, I mean, the gradient's obviously negative, but they're saying, what was it? Work out the rate at which the water is flowing. Think about the context of rate. No, I know the gradient's negative, but if you think about the literal rate of water, the negative, it's kind of like when you have like, you can't have a negative area. Like in terms of the context, the negative is irrelevant, isn't it? They're looking just at the number. Same kind of thing here. You can't have negative liters technically. So I know the gradient is negative, but as in terms of the context, it's just that how many liters, a positive number of liters per second, isn't it? This is really straightforward. You just have to know basically what this is asking, like what is the actual topic underneath all of this context. This is another simultaneous equations one, but obviously now it's quadratic and obviously linear. The fact that they'll only have 1 point in common, you don't really need to worry about that until the end. I know obviously you're thinking, well, quadratic equations and simultaneous equations always have 2 answers. You'll see why we only end up with 1 at the end. But this is effectively, whenever they say have 1 point in common, sometimes they use the word intersection, show that the 2 graphs intersect or whatever, or find the coordinates of where they intersect. That's just like simultaneous equations. Because if you imagine it on a graph, where they overlap or where they cross each other, where they intersect, it's where they both have the exact same x and the exact same y values, where they both are equal, isn't it? So this is just quadratic simultaneous equations. So the first one, I'd probably rearrange the linear, because normally with quadratic simultaneous equations, you substitute the linear one, like the more straightforward one, into the quadratic, don't you? So I would probably just make y the subject. I think that's the easiest thing to do. So add 5x minus the 4. And then do you see how that's equal to y, that's equal to y? So I can just make those two equal to each other. Well, you solve them together, if that makes sense. So I'm going to put 5x minus 4 is equal to x squared. Because it's true, because we're looking at the point of intersection, or the point they have in common. It's where they're both, like in terms of this, the y would be the same value, the x would be the same value. So I can just write that they're equal to each other, can't you? So because this is a quadratic overall, the way we solve quadratics is we need everything on one side, 0 on the other. And I'm going to move these to the right just because I want to have x squared positive. So that's how I choose. You might have written it the other way around to me, that's fine, doesn't really matter. So minus the 5x, so that'd be minus 2x, add 4, so that's plus 1. Now, normally, you can obviously use quadratic formula if you want, because it is a calculator paper, but this one should factorize. So you factorize it or use a quadratic formula, it doesn't really matter. But do you see how you get x and x, obviously? We get 2 negatives, and then obviously factors of 1 is just 1. So you do get 2 solutions, but do you see how the solutions happen to be the same number? It's like x is 1 or 1. Well, that's obviously the same thing, isn't it? Yeah. Yeah, you can write it like that, like one of these brackets squared, exactly. So quadratics will always have 2 solutions. However, it doesn't mean that they're different solutions. They might be the exact same solution. Now, actually, you don't actually in this case, because it says show, you actually don't technically need to find y. I mean, you can, obviously. You just take this and substitute it back in. You don't actually have to, though, because this, you just have to write a little conclusion. You don't need to know. I actually did when I did it. I just kind of got carried away and started finding out why. But actually, you don't need to, because you do need to actually write a kind of a conclusion, though. So you say, well, there's only one solution to x, so therefore that's only one point in common, isn't it? You see the wording that they gave. Yeah, you have to have a statement. One only, oh, it's meant to be a y. One solution, or some version of this, right? For x, therefore only one pointing, or whatever they've said in the question, point in common. You do have to write that kind of conclusion, though. Yeah. How do we know we make them equal? Because do you see how this one is the exact same as the, let me highlight it. This is the same as this, isn't it? I just moved it around, didn't I? I just rearranged it. And then when you're solving quadratic simultaneous equations, the method is you always, in some format, take the linear one. When I say linear, I mean this one that's only got x and y. It's not squared, is it? It's just like a straight line. You take that one and you always substitute it into the more complicated one, the quadratic one. Now, if this equals to y and this equals to y, y is the same thing, isn't it? Y is the same thing on both sides, so they are equal. So I basically oh, where's my pen gone? I basically substituted this into y, if that makes sense. It never said, but it's implied. That's just how because they share this, because we're talking about the point on the graph where they overlap. It is the point where they both have the same y, isn't it? If you think about that in that context, where they overlap on the actual graph is exactly where they have the same value of y. So y is the same thing. If that makes more sense. I'm trying to get it on Desmos so you can see. Oh, it's not very obvious actually. But yeah, it's where they both overlap. So they will have the same y value. Yeah, because it's in common. I think the other thing about not having to find, I mean, obviously if you find the y coordinate, you'll still get the marks. But do you see how it's only 4 marks? I feel like quadratic simultaneous equations is normally 5 marks, so maybe that's why it's only 4, because you don't technically have to find out the y coordinate. Obviously you can, you just sub it back in, but you don't technically need to for this particular question. Now, question 17, we do have proportion, which I think you got basically a very similar question to this in your paper 1. So again, whether they'll ask it another time, I don't know. But I think this was quite similar to what you had. So x is directly proportional to the square of y. So when we were looking at the graphs earlier and I wrote down the equations, the formulas, that's what I'm going to use. So x is directly proportional to the square of y. So x is equal to k y squared. It's direct. Y is also directly proportional to the cube of z. So y is directly proportional. Now, actually, I'm not going to use k because technically they're 2 different values, aren't they? I'll use c. But the c and the k are just constants, aren't they? Yeah, I found the paper 1 on what's it called, on TikTok. So at least I could have an idea of what you guys have already seen. Yeah, loads of people posted it online. You could probably find it. I just screenshotted it like on the day. So I'm setting up these 2 equations. K and C, as I said, are just constants. They're just numbers that we obviously right now don't know. They've then said that z is 2 when x is 32. Find a formula for x in terms of z. So what they want is x equals, as a subject, something, 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 z. That's what we're looking for. So do you see how that means we don't want Y? And we also don't want K or C. The only letters we want at the end are Z and X. Yeah, exactly. I think this came up in paper 1. I mean, I've kind of vaguely read the questions. I haven't done it myself. I don't know if it was hard. I think it was just that a lot of people were thrown by the structure, and because it says so many 5 markers, they thought it meant really hard. But as you saw, you can get a 5 marker on question 3. It doesn't mean that it's a hard question. It just might mean that it's a longer question. So I think some people were kind of thrown by the structure of it and thought it was really hard. I don't know if it was much harder than normal. I think it was all the same stuff. Yeah, I don't know. I mean, I'd have to sit through it and actually do the questions myself, but from the topics that I saw, it was kind of a lot of things that I thought would come up anyway. They've just laid it out maybe slightly differently. So I think this one's actually a bit harder. As you said, November papers I think are a bit harder because we've only been given 2 values. So you could sub in... What was I thinking to do with this? I think what I would do is I would sub this one where it's y is equal to into the first one just to get rid of the y's, because you know how I said we can only have x and z at the end. So I would do this probably first. So you get k, and then in brackets you get c z cubed squared, and then if I expand that I get k c squared. I know you could probably technically put c at the front, but it doesn't really matter. Z to the power 6. So I've got that. Obviously, the problem with this is that I don't want K and C. Yeah, I don't want to have that in the end. So, and I haven't used my numbers yet, so there's obviously a point to why they gave us the numbers. So I think I would substitute in 32 and the 2. 32 is equal to K C squared, and then 2 to the power 6. That's 64, isn't it? I'm just going to check. Yeah. Well, let me rewrite that. Is 64 K. And then do you see how I obviously can't solve to find K and C separately? Because again, as I said, 2 letters, you need 2 numbers. You need 2 equations. I can't do that. But what I can do is obviously rearrange this. If I divide by 64, I get half. So this as a whole is equal to a half. Do you see how then I could just replace the whole thing? I don't need to know. Yeah, exactly. I don't need to know what K is separately to C squared and so on. I just need to know that's a half. So therefore, X is, you can write it as a half Z to the power 6, or as you've put in the comments, you could write it as X is equal to Z to the power 6 over 2. Same thing. Doesn't really matter which, that was a horrible 6. Doesn't really matter which way around you do it. Oh, those both look like Z's, don't they? That's meant to be a 2 in the denominator there. Let me redo that. Yeah. Either of those. But I think this was a harder version. Like, I've seen lots of these where it was 2 lots of proportion, like 2 different proportion relationships, but it's more straightforward than this. You just sub in the numbers. This one I think is harder, like we said, because it is November. Yeah. Oh no, yeah, make sure you read the question right. This topic is proportion, so direct, well this was specifically direct proportion, but obviously that does also include inverse proportion. Yeah, they could ask you another question. I don't know, there's nothing to say that they won't. I have videos on proportion anyway, so you can always have a look on my channel at the actual videos. If you go through, I've got a video on direct proportion, I've got one on inverse proportion, and then the worded inverse proportion, you know, the one that we saw. What question was that? There was a question at this, question 12 or something, was it? I can't remember. There was a question with the workers cleaning cars. So yeah, you can have a look on my channel if you want to see. But yeah, I think this was a harder version of the normal question, but I do think you got this question in paper 1 anyway. So if they ask proportion again, it'll be slightly different. How many marks was the one in paper 1? I feel like it was towards the, I can have a look quick. I feel like it was towards the end. Hang on, let me just find my screenshots. Let me just check. Hopefully I can see it. Oh no, I'm completely wrong. It was question 11. It was 5 marks. but it was an easier one. It was the one where they do give you enough of the numbers. It was an easier one. But it was 5 marks. Question 11. Yeah, it was like, well, you didn't have to do a probability tree, but I probably would have worked it out myself using a probability tree. It was technically it was at the end of the paper, I think, so it was kind of a harder one, but if you knew what you were doing, because I had seen something fairly similar before, so if you knew what you were doing, I think it was okay. But if you obviously hadn't seen it before, it was quite a lot to take in. Yeah, it was quite a lot to kind of interpret, wasn't it? Okay, question 19. So at the start of year n, the number of animals in a population is Pn. At the start of the following year, the number of animals in the population is obviously then Pn plus 1. Now they've given us this formula. So to find the population for the second year or the following year, you take the previous year and times it by k. So they've then given us two numbers. So we've got the start of 2017, the number of animals in the population was 4,000. And then at the start of 2019, just pay attention to that, it is 2 years different, not just 1 year's different. The number of animals in the population was 3,610. We need to find the value of k. So what I was doing with this one, how did I lay it out? I feel like we've skipped one. Have I skipped one? Yeah, I've just skipped one. Hang on, let's go back. I was thinking we missed the vectors one. Actually, for being vectors, this wasn't even that bad. So let's just do this one really quick. So the OABC is a trapezium. You can see they've obviously labelled these 3 vectors. They've then given us some ratios. D is the point on OB such that OD to DB is 2 to 3. I tend to label it, but just remember this is not the vector, this is just a scale, right? E is the point on BC such that BE to EC is 1 to 4. And then work out the vector DE, so this line here. So this is quite a nice one, I feel like. Because it's at least not a ratio. Well, there's obviously ratios in it, but it's not asking you to find a ratio, it's just asking you to find a vector. So I was thinking, right, D to E, I would probably go D to B, B to E, right? Which means, if we backtrack a little bit, I would need to know O to B first. That's quite easy, isn't it? That's just A plus B. And then I would also need to know B to E, which is the whole of BC, isn't it? So I'll write that down. Actually, let me write that somewhere else. BC. So B to C, you could obviously go back down OB and then across, or you could go all the way around. It doesn't really matter. I think I just went all the way around. So minus B minus A because I'm going the wrong direction, plus 3B, which I'll obviously then simplify to 2A minus, no, 2B minus A. Yeah. And then I just applied, obviously, the ratios. So you need to convert them into fractions for the section of the line that you want. So from OB to DB is the 3 part, isn't it? So that's 3/5 because you add up parts to make the denominator. So that's 3/5 of the whole line OB. So you can obviously expand that if you want. And then over here, BE, again, using the ratio, is actually 1/5, isn't it? Because I want the smaller part of 2B minus A. And then the last thing is to just add those together to get DE. So DE is DB plus BE. Have I written that right? Yeah, DB plus BE, yeah. 1/5 2B. Now, obviously, they do want you to then expand it and simplify it, so there's that. So let me scroll down a bit. So you're just kind of expanding and simplifying at this point. So we've got 3/5 A plus 3/5 B plus, that would become 2/5 B minus 1/5 A. So then you see how I get 2/5 A, just be careful you're adding the right ones together, plus just a whole B, isn't it? 5 out of 5, a whole B, yeah. So that should be your answer, 2/5 A plus B. So I think that was a fairly straightforward vectors one, to be fair. Now let's just come back to question 19. This one's quite nice. So I just kind of subbed in the values to the formula. So to find the population of 2018, I would do obviously K times 4,000, which is 2017, isn't it? And then to find the population of 2019, you would have taken the whole of that and multiplied it by K again. So that would obviously be 4,000 K squared. But I actually do know that that equals 3,610. So you could look at that as an equation if you wanted. A little arrow instead. You could look at that as an equation and just solve it from there. So 3,610 divided by 4,000 is 0.9025. So that's K squared though, not just K. Was that right? 9025? Yeah. And then obviously square root it, which gives you 0.95, which seems like a reasonable number, doesn't it? Seems like, yeah, that makes sense. So actually the population is technically decreasing. And as you can see, obviously it did, didn't it? So yeah, if you didn't get circle theorems in paper 1, I feel like there's a very, very, very good chance it will come up in, you know, either paper 2 or paper 3. I don't know which one, but yeah. All right. I think question 20, I think this is one that we've seen one similar to this before. It was a different context, but it was basically the same question. But I think, yeah, it seems confusing, I think, initially, even though it's only 2 marks. So they have repeated this question technically before. Yeah, they have done this question before. I think, what was it with? I can't remember. There was a different context that wasn't a coin, but it was the exact same question. So this one they might repeat, I guess. So Pat throws a fair coin n times. Find an expression in terms of n for the probability that Pat gets at least one head and one tail. So at least one of each, at least. The problem is we don't know how many times Pat is going to throw it. So I'll kind of show you in terms of like a tree, but you don't have to draw this obviously if you're working, but just to kind of explain it to you. Obviously a coin, you can only get heads or tails, right? There's only 2 options. So if they throw it once, head tails, you see how obviously it's a fair coin, so it's a half and a half, isn't it? 50-50 chance. And let's say they throw it again. Do you see what I mean? You'd fill out the table like this when you, well, the tree, I guess, like this, half, half and half, so on. It's all a half. Now, the problem is that we don't know how many of these columns, do you know what I mean? It could go on forever. It's n times. We don't know how many there are. So they want at least one head and at least one tail. Well, the problem with that is that it could be any combination, like any, do you know what I mean? It could be almost any combination. We obviously can't account for all of those combinations because we don't know how many times they're throwing the coin. The only thing that we can account for is, if you think about it like this, if they get at least one head and at least one tail, there are only 2 options that they definitely cannot have, or 2 branches that you can't follow. And that would be that they cannot get all heads, head. You see, this one would be like all heads, wouldn't it? Because they have to get at least one tail. They also can't have all tails because they have to have at least one head. So that's the only thing that we can account for. All the chances of getting heads, all the chances of getting tails. Everything else in the middle would include at least one head, one tail. So what I'm going to do is write an expression for the orange, write an expression for the green, and then do 1 minus both of those. Okay? So the expression for the probability of just, let's say, all heads is it would be a half times another half times, wouldn't it? We don't know how many times that is. It's n times. So the way that you can write that is 1 over 2, 1/2 to the power of n, isn't it? N times. Because you're timesing it by itself n times. The exact same, I'll write it down here, for all tails, because it's the same amount, isn't it? So half, a half times 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 a half, n times. And then it's just 1 minus that. So like I said, you don't need to draw the tree. I'm just kind of trying to draw it so you can understand what I'm saying. So the probability of getting at least one of each would be 1 minus all the heads minus all the tails. So that's the answer. Yeah, that's where you get the power of n exactly, because we don't know how many times we've multiplied a half by itself. So it's the same as squaring, cubing to the power of 4 to the power. Do you know what I mean? It's the same to the power of something, isn't it? Can it be written like that? No, I don't think you can. No, I think when I saw the mark scheme, the answer was literally just left like this. Yeah. But I have seen another question that asks very similar thing. So yeah, this one might be a repeated one, I guess. Question 19, I just basically subbed in the values, right? Like to find out 2018, I subbed in 4,000 times k, which is obviously 4,000k. Then to find 2019, you would sub in 4,000k times by k, which gives you k squared. Well, 4,000k squared. But the 2019, we do actually know that it equals to 3,610. So then that's just an equation that I solved. And then I got k as 0.95. I don't know if you want me to explain it in any more detail than that, or if that is fine just to read through it. So I got the k squared because if you look at the formula, do you see how effectively you take the previous answer and you sub it in to the formula? The previous answer was 4,000k. So, but then I have to times it by k. Like every year you have to times by k, don't you? So if you think about it like that, 2 years is obviously k squared, isn't it? Because you see how the difference was 2 years? It was 2017 to 2019, it was 2 years. So for 2018, it was just 4,000k. But then for 2019, it was 4,000k times by k again, which gave me k squared. Yeah. I guess you could do that. Oh, yeah, let's write it like that. So you could say that equals to x, which is an unknown value, and then you'd sub that in, wouldn't you? I guess the problem with that is that then you'd go, well, x k is equal to 3,610, but then you see how I now have 2 letters that I don't know, and again, we're coming back to the same thing where you can only have, if you've only got one equation, you can only have 1 letter. We've got 2 letters, you wouldn't be able to, like, where would you go kind of with that, I guess? You would have to use the 4,000k. So I probably wouldn't. I'd probably just leave it with the k. Yeah, it is. Yeah. The xk would represent 4,000k squared. Yeah. If you were to do it that way, but I think you'd then get stuck. I don't think you'd be able to solve it after that. So you just go back to using 4,000k squared anyway. It's literally just substitution. Like, all I've done is substitute numbers in. That was kind of it. Yeah, it's effectively iteration, but obviously without using anything really to do with iteration. It's just the context is loosely that. Yeah, that's true. Yeah, but that one was just subbing in value. I mean, that's just algebra, really. It's more so to do with algebra than iteration, if anything, isn't it? Oh, this is the question I was saying that this came up in your paper as well. I think it was part A and part B. you had the tangent one, then you had this, or something similar to this. So again, I don't think they'll ask this twice. It's quite specific, isn't it? But we'll look at it anyway. So 21, here is a speed time graph showing the speed in meters per second of an object t seconds after it started to move from rest, using 3 trapeziums of equal width. Work out an estimate for the area under the graph between t1 and t4. Yeah, area under the curve, exactly. Just be careful though, they have said 3 trapeziums. I know it's normally 4, but they have said 3 this time, and between 1 and 4, so we're not using this first. Well, that would be a triangle, wouldn't it, I guess? So obviously our trapeziums are like vertically stood like this, aren't they? There's 1 to 2 would be one of them, and then 2 to 3, and then 3 to 4. And then you just have to read off the axes. I think the equation, yeah, the formula for the area of a trapezium is on your formula sheet if you didn't know, but yeah, you probably know what it is anyway. Yeah, a plus b over 2 times h. No, but the formula for trapezium is on the formula sheet. Yeah, it's on there. So A and B are obviously the parallel sides, which in this case are the vertical sides. Sometimes it's the horizontal sides if it's a different question, right? But in this case, they're the vertical sides. So obviously here you're going to read that's 1 and that's 6, isn't it? So for the, maybe I'll label it for 1, that is 6 plus 4, or 4 plus 6 over 2 times by the height. Now the height is then the difference, isn't it? The width in this case, which is 1. So that kind of makes no difference really, does it? That one's 5 for 2, and then you do the same. Obviously we know that that one's 6. This one I think I said was like 7.2. Just be really careful of the scale. 7.2 plus 6 over 2. Again, technically times by 1, but that makes no difference in this particular case. What did I get for that? Oh, I just added them all up straight away actually. I didn't even work out individually, but we can do that if you want. 7.2 plus 6 over 2 is 6.6. And then 3 obviously then starts at 7.2, and I think it goes up to like 7.8. 7.2 plus 7.8 over 2, technically times by 1, I think is 7.5. But let me just double check so I don't get that wrong. Yeah. And then obviously you add those together, right? I think you could obviously just type into your calculation one step if you wanted, but so the total area would be 5 plus 6.6 plus 7.5, which I think should give you 19.1. Let me just check the comments. To be honest, for A-level, there was just, they gave us like literally like a 20-page book. I'm pretty sure it was like a massive booklet. Like you get more formulas at A-level. And obviously all the others are kind of drilled into you by that point anyway. Because also I had the formula sheet before COVID, so in my GCSEs, I didn't have as much as you guys have now. And you just had to drill it in. You know, over the years it kind of just naturally, I feel like, went in. Well, in this case we don't need the triangle because they've only asked for 3. Obviously, if in the case you did have a triangle, then you'd add that as well. Yeah, there's not a lot anyway, and we had even less after that. The one in the brackets is technically the height, because you know for the area of a trapezium is a plus b over 2 times by the height. The height is the, do you see how the height is 1 every time, like the distance is 1? I know that technically it makes no difference to your calculation, but I'm just writing it for, just for the marks, right? Just to be technically correct. Let me check the mark scheme, what do they say? Yeah, I don't know. Not really. They're just saying for like, you get 1 mark for showing that you've at least calculated one. Whether you put the answer or not doesn't really matter. It's the fact that you've gone through the process of calculating one trapezium. 2 marks for the fact that you have done all of it. And then obviously then the 3rd mark is just for the answer. Yeah, so then it says, what does this area represent? It's the distance, isn't it? Because we're effectively doing speed times time, which is distance. Distance or distance travelled. Yeah. But yeah, as I said, I think you already got that question, so I don't think they'd ask it again. Like, there's kind of, once they can prove that you've done it once, they're not going to try and get you to do it twice. You know what I mean? I think it's too specific for that. How many have we got left? 1, 2 more. We've got a nice algebraic fractions one, which you haven't had an algebraic fractions one yet. Well, there was one fractions question, but it wasn't like a massive question, so I feel like this could come up again. They've been given a weird graph question for container filling. I don't know what you mean by that. I don't think so. So 22, this is only 3 marks actually, this one. Show that 6x cubed over 9x squared minus 144 divided by 2x power 4 over 3 brackets x minus 4 can be written in the form 1 over x brackets x plus r, where r is an integer. The other thing that also always comes up is some form of, you can hopefully recognize what this is. This will always come up, whether it's in algebraic fractions, whether it's in a different question. It could be in any kind of question, but this formatting here will come up. So when we're obviously working with algebraic fractions, normally I try and, you could divide it first if you wanted. I tend to try and simplify it first, I guess. What I mean by that is I'm going to factorize. So obviously the numerators you can't really do anything with, so I'll just leave those there for now. Now this denominator here can be factorized kind of in 2 different ways. It's either way, it's difference of 2 squares. Yeah, this is what I want you to recognize because it's so easy once you know what it is. But what we can actually do, and I don't know if I knew this to be fair, but you could actually pull out the 9, as in you could factorize out 9. You get x squared and you get minus 16. I didn't know that, to be fair, as in I wouldn't have recognized that 144 was a multiple of 9, but anyway. The reason why I do that is because then it will simplify, I guess, further at the end. And obviously then that can factorize into difference of 2 squares. X plus 4, x minus 4. I guess also the clue is the fact that they have this kind of other bracket here. So you can see that's one of them. Divided by, now that one doesn't, obviously, there's nothing you can really do with that, is there? Not going to expand it, just leave it as it is. I'd probably then, I guess, do keep flip change whilst we're here. You can probably do it all in one step if you really wanted to. Now, you can write it all multiplied together if you want, or you can just start cancelling it out as it is. So I know that the whole of the x cubed will cancel, and I'll still be left with an x here. Do you know what I mean? Like, you can start cancelling it like that if you want, or you can just multiply it all together. You could simplify this bit first if you wanted. I mean, it just depends. Let's say we multiply just so we can see everything. Don't expand out the brackets, that's not what I mean. We get 18 x power 4 x plus 4. There's different orders of doing this one, so you might have different numbers to me, but as long as at the end we get the same thing. You can see the 18s cancel, the x cubed cancels, but then you still get an x here. Obviously, that cancels. Now, because the whole numerator cancels, it's not like there's nothing left. Obviously, it's not a 0. There's still a 1 there, right? So don't let that disappear. X plus 4 there. That's what I got. But you might have done it in a different order. As long as you end up with that same kind of, the 4 is basically the number, isn't it? Okay, so hopefully you got that. Just checking the comments. Yeah, so what I was saying about the difference of two squares is you can, obviously it does separate like that, that's fine. You can also do 3x plus 12 at 3x minus 12. However, do you see how like my answer, it has an x, it's not a 3x, so it's not a number in front of the x. So if you did that, you would still then have to pull out the 3 from both. So do you see how I could factorize out 3 from that, and I get x plus 4, and then I could factorize 3 from the second one. And then that's where the 9 comes from. So you could do it that way round as well. Yeah, it doesn't really matter as long as you do end up factorizing out either the 9 initially, which is what I was saying, is I probably wouldn't have noticed that myself. I probably would have just factorized it straight and then gone, oh yeah, I can factorize out a 3 and a 3. It doesn't really matter the order as long as you get to the same thing at the end. The whole point is that you should get a 4 for where they have R. And that one's 3 marks. So yeah, I feel like some kind of algebraic fractions question could be, you know, definitely a possibility for paper 2 or paper 3. Now the last one, this one I think was really weird. How can you factorize 3 out? Wait, hang on, let me go back. Because you see how you've got 3x and 12? 3 is obviously a factor of 3 and 3 is a factor of 12, so it means I can pull it out, I can factorize it out. And the same here, so you get 2 3s, which then 3 times 3 gives you the 9. If you did it that way, that's fine. But I knew I had to factorize out the 3 because there was nothing in front of the x in the answer. Hopefully that answers your question. Now the last question I thought was really hard, to be fair. I think it's one of those wild card kind of questions where you're just like, I probably have no idea. Yeah, I was just like, it's such a weird question, and again, not one that's probably easily repeatable. Now, there are technically 2 ways of doing it, which are kind of completely different, so I guess it depends which you prefer. Let me see. I think, oh, I wrote down that there was either you could use sine rule or you could use area of a triangle, basically. I think when I first did it, I think the area of the triangle one made more sense to me, but then that's a very personal thing, isn't it? So we've got obviously a triangle. D is the point on BC such that the angle BAD is equal to x, and the angle DAC is equal to x. They're both equal to x, they're both the same exact angle. Prove that you can create this equation. So we obviously need to create an equation, but we've got 2 triangles, haven't we? Yeah, I could show you both. So I'll do the area of the triangle one first. Obviously, we need to create equations using the angles, using formulas that we know. We know about, obviously, trigonometric area of a triangle. We've got that formula. We've got like sine rule, cosine rule, that kind of thing. But they all have angles in. So at the end, we're ending up by cancelling out some of those things, right? We don't want to have an angle at the end. So the one where we're doing the area, I think you have to do the area for each. Now, I know they're not the same area. You can see one's obviously bigger than the other. That's the other issue, isn't it? So let's say trigonometric area of a triangle, if I write it, it's obviously on your formula sheet, but half AB sine C. Now obviously in this case you could swap the letters because we want to base it on this angle here, don't we? So let's say for this triangle ABD, I think that's the one that we're going to do. Yes. The area of triangle ABD, if I were to use this, and we're going to use like the sides in terms of AB and so on, right? Because that's what they've got in the answer, would be a half, and then it's the 2 sides around the angle, isn't it? So you see how that would be like AB multiplied by AD, and then sine X. Now, I can't put that equal to the other triangle. As I said, they're not the same, are they? They're not the same area. So I think what you had to do, which again, I probably wouldn't have thought to do this myself, honestly, was go, well, what's that equal to? It's equal to itself, but obviously we want to have BD, don't we? We want to have one of these sides and then a base. So think about the other area of a triangle. You've got area of a triangle is half base times height or base times height over 2, just the normal one, right? In that case, for the same triangle, ABD, half, the base is then BD, isn't it? The base is BD, and then the height is technically, it has to be a perpendicular height, doesn't it? I'll try and draw that accurately. Would be like this. Now, we don't have a side for that. We don't have a label for that. I just think this is so, like, unnecessary. But anyway, I'll just put H. Again, I know that we don't want H at the end, but there's that. Now, do you see how I could make those equal to each other? Because they are the same triangle. It's the same area. So I've got half A. I don't think this is worth the marks, honestly. Sine X is equal to half B DH. I guess you could obviously cancel out the halves if you really wanted. Those would just disappear, wouldn't they? And then the thing is, what I'm saying with that is I would then do the same for the second triangle. Let me move this over a bit. So do the exact same for the second triangle. So the area of triangle, what's that one? ACD. Trigonometric would be half AD times AC sine X, and then do the same. So the area, but with just the normal one, is a half. The base is DC, but do you see how technically the height is the same for both? Okay, so there's that. And then you can put those equal to each other. Half AD AC sine X is a half DC H. And again, if you wanted, you could cancel out the halves. They're kind of not really helpful. And then you just have to try and get these two to be the same. As in, that was really badly explained. You're trying to get these two separate equations into one, because we obviously only want one answer, don't we? One equation at the end. So what I was thinking is I also, have a look at them. I also don't want sine X in either. I don't want the H, the height, right? I don't really want that in my answer. What have we got? AB. I don't want AD, but they have AD in both. What I'm going to do is divide them, basically, because that will cancel out all the things that need to be cancelled, and you can see that they're divided here, aren't they? So you could just divide them. I don't think it matters which way around you divide them. But let me just write down this one below. AD. AC sine X is DCH. Do you see if I divided those? Well, let me write the halves so you can see the halves and I cancel. Obviously those have all cancelled, haven't they? We don't have the halves. But do you see how like the halves would cancel, the H's would cancel, the sine X's would cancel, but also the ADs would cancel because there's ADs. And then, do you see how you're left with, I know it's really messy, but you're left with AB over AC is BD over DC. Now just check what they've got. They've got it in a different order, so just rearrange it. So you basically need to just swap the AC and the BD, isn't it? So divide by BD times by AC, you'd end up with what they have. That's one way of doing it. Let me have a look at the comments. How many marks? Yeah, 4 marks. I don't think it's worth it. Yeah, I honestly don't think it's worth it. I wouldn't even know where to start with this, to be honest, especially not if I was like doing it now. Like if I was in year 11 now, I'd have absolutely no idea where to start with this. Yeah, it's not even 5 or 6, so to be honest, might as well just leave it. The next one's on Wednesday. The next paper is on Wednesday. So that's the area one. You can use sine rule if you want. I don't know if you want me to also go through that one. Don't know if you think it's worth it, to be honest, but you can use sine rule to do it as well. So it's up to you guys if you want me to go through the other version or not. The hardest form of question. I guess something like this, some kind of like proof one, but not just general algebraic proof, like one like this, where you just have no idea where to start, isn't it? But then, like one where they're saying show that, and you just don't know where to begin. When I say how long to stay on each question, I would say like a minute per mark. So like, let's say this is 4 marks, I would say 4 minutes, which I know it would technically take longer, but try and stick to that. I don't know. I mean, when I was doing it, I didn't normally like count every single minute, right? Obviously that would then take too long as well. But it was like, if I got to a question where I felt like I was going to be quite slow or I wasn't really sure what to do, I would, before I kind of spent too much time on it, I would have a look at how many marks it was, say, right, I'm going to give myself another 3 minutes, for example, check the clock, because there should be a clock in your exam hall, obviously, or if you've got a watch, check that. And then after that amount of time, if you haven't made any kind of progress, or you're not about to finish writing down something, then move on. Yeah. There's not one tomorrow, because I have other tutoring sessions on a Tuesday, unfortunately. That's why I've never done Tuesdays. Yeah, so like you might end up having, let's say, a 4-mark question, but you end up doing it in like 3 minutes. So you know what I mean? It's just for those questions where you're kind of stuck and you're like, let me make sure I don't spend too much time on it. Yeah, maybe when you're doing your past papers, try and give yourself a timer, and even like for each question, maybe go, right, I'm gonna give myself 4 minutes, put 4 minutes on the clock and see, and then do the question and see. It's just more of a case of remembering to keep checking the clock, I think. Because sometimes you can kind of forget, can't you? You can get so invested in the paper that you just don't look at the time at all. You don't realize how much time has gone past. So I think it's probably best to just try and get used to keep flipping your head up and looking at the time, making sure you're happy with it. I know there's some people who, what they do is they might do the first, I don't know, maybe the first like 10 questions or maybe less, do a few questions just to warm up. And then what they do is after that, once they feel like they've kind of warmed up into it, they'll just go to the back of the paper and work backwards. So at least then, when you're then rushing for time at the end, you might find that you've got easier questions to deal with. I don't know. That's up to you whether you think that's a good strategy or not. That's just a personal thing, isn't it? A great boundary for the paper. What was this one? November 2022, right? Sorry, 2021. Let me paste it. 3 is 23, 4 is 37, 5, 65. This is out of like, yeah, this is out of the 240. You have to divide it. 6 is 93, 7, 121. Just divide all of these by 3. 9, 187. Okay, alright. So you got 68. Let's say you got that on all 3. Well, that would have been a 9 then, no? 187 divided by 3. 62.3 recurring. Yeah, so you got a 9. Alright, perfect guys. Okay, thanks for coming. The next one is, as I said, on Wednesday. You can see they're listed on my channel anyway. You can see they're all like scheduled for this week. I think I might do some more over the weekend because it's half term, isn't it? We'll see. And the next one, let me find what it is. We're going backwards, so I'm assuming, I feel like it's gonna be the 2020 paper, but let me double check. Yeah, Wednesday. Yeah, June or November 2020, because obviously it's the same paper, isn't it? Yeah, I was thinking, we've obviously got Wednesday and Thursday. I was thinking I could just do Friday and Saturday anyway, as well, if you wanted. And obviously it'll be next week as well. Sorry, yes. Yeah, that'll be paper 2. And then on Thursday, we'll therefore do the same year, 2020, but paper 3. And it's a June. Yeah, well, it's technically, because it was COVID year, wasn't it? I think what happened is they wrote the paper for June 2020, but it never happened. So then they just moved it to November. So when you go onto the Edexcel website, I think it's listed under November. But it is kind. I think it was meant to be the June paper, which is why I've called it June/November. Because yeah, 2020 only had one paper, didn't it? Same with 2021. This one was the only paper in 2021. So yeah, it's the 2020 paper basically. I think I've linked it in the. If you go on to that actual live, you can see it's scheduled. I think I've linked it in the description anyway, so you can find it. Or obviously on the Edexcel website generally. But yeah, so we'll do paper 2 on Wednesday, paper 3 on Thursday, then maybe Friday, Saturday. What would that then be? June 2019, 2 and 3. I'm just alternating between paper 2 and paper 3 because obviously the topics are mixed, so you just don't know what's only paper 2, what's only paper 3. So yeah, we'll do that. But yeah, perfect. All right, guys, thanks for joining me today. I'll see you. The next one, as I said, is 7 o'clock on Wednesday. And then hopefully we'll just do every day from there.